Hi, hello, and welcome to Homework 13 Studies video. We're going to go through multiple representations of linear functions, which we've been working on for a few days here. I'm going to go through this example with y'all. You're going to complete the example on the back yourself. Okay? So on this one, for my equation, I've got y equals 1 over 2x minus 4. Remember, this equation is in our y equals mx plus b form, where the gradient is represented by m, the gradient or the slope, and the y-intercept is represented by b. So here, I'll color code this, make the y-intercept in purple. Our y-intercept is where b is. B is the number by itself here, so my y-intercept is -4. For my gradient, or m is the number that's being multiplied by x, or in front of x, so my gradient here is 1/2. Now, to convert from an equation to a table, we can plug in values for x to find y values. So I usually just pick the numbers 0, 1, 2, 3, and 4, but you can really pick whatever numbers you want to plug these in. So I've got this equation here, y equals 1 over 2x minus 4. So wherever I see x, I'm going to plug in a 0 here. So I've got 1 over 2, 0, minus 4. So I'm using my original equation, and wherever I see an x, I'm plugging in a 0. So when I plug that into my calculator, I'm going to do 1 over 2 times 0 minus 4. When I plug that into my calculator, I get -4. So I know my y value here is -4. I'll do one more with y'all, and then I'll let you do the rest of them yourself. Same thing here, I'm using my equation 1/2 parentheses x. Wherever I see an x, I'm going to plug in whatever value is in this x column. So here I'm going to plug in 1 for x minus 4. Same thing, type it in my calculator. 1 over 2 times 1 minus 4 gives me -7 over 2. If you want to, you can convert that into a decimal, so it's -3.5. So here is -3.5. I'm going to let y'all fill in these next three. On the graph, well, I already know what my slope and my y-intercept are. And then to get from a table to a graph, all we need to do is plot the points. So plot the points that we've generated. So here, I'm going to start with this point first. I've got the point 0, 4. Now remember, x is my left or right movement, y is my up or down movement. So here is 0, so my x value is 0, so I don't have to move left or right at all. And then -4, since it's negative, it's going to mean down 4 units. So I go 0, and then I go 1, 2, 3, 4, -4, and I plot my point. Okay, next point that I'm going to look at is my 1, -3.5. So this one, my x value is 1, and it's positive, so that means I'm moving to the right. So I go 1 unit to the right, and then I've got a -3.5, which means I'm moving -3.5 units down. So I move 1, 2, 3, and about a half. Okay, you're going to plot the rest of the points that you've come up with here. When you're done, make sure you connect them together so it forms a line. Okay. Last thing for our multiple representations, it says the graph of the function contains the point. You can choose any of the points you've written down so far. I'm going to choose this one. So the graph of the function contains the point 1, -3.5, because that's a point listed in my table. And when the value of x increases by blank units, the value of y increases by blank units. This comes from our gradient. Okay, whatever our gradient is, remember that a slope is, our gradient is essentially change in y over our change in x. Okay, so my gradient is 1 over 2. So when x increases by, that's the denominator of my fraction. So when x increases by 2 units, the value of y increases by 1 unit. X is whatever value is changing on the bottom of the fraction. Y is whatever value is changing on top of the fraction. Okay? So you're going to take what you learned here and complete the one on the back as well. We'll do one ACT problem together because all of these look pretty similar. Okay? So we're going to do this ACT problem down here. It says, which of the following equations represents this relationship between D and T? Okay? Now this is something we haven't done as much, going from a table of values to an equation. But remember, we know how to write equations in y equals mx plus b form, where m is the slope or the gradient, and b is the y-intercept, or where the function touches or crosses the y-axis. So I'm going to look for slope first. We'll notice with slope, it comes from the change between 2 points next to each other. So from 12 to 17, I'm adding 5. 12, 13, 14, 15, 16, 17. Had to double check myself there. Mental math is not my strong suit. So I have plus 5 here. From 17 to 22 is another plus 5. From 22 to 27 is another plus 5, another plus 5, and another plus 5. So I'm changing by 5 every single time. And I'm changing by the same amount every single time, so that is my slope. My slope is 5. Now the y-intercept's a little bit trickier. The y-intercept is where the function touches or crosses the y-axis. Okay? This can be where, this is where it kind of helps to plot. So if I'm going to sketch out a little graph here, I've got the point 0, 12. So that means I move left or right 0 units, and I move up 12 units. Okay? If I plot it just like that, this is where, at 0, 12, where my function touches or crosses that y-axis. It's where this point is on the y-axis or the up and down axis. So my y-intercept here is 12. So if I'm writing this out, I would write it as y equals 5x plus 12. The one that looks closest to that is my answer choice of C. And that is all for the homework video. I hope you have thoroughly enjoyed linear equations as much as I have. If you have any other questions, send me a message on Google Classroom. Don't forget to like or subscribe. I'm almost up to 20 subscribers. Big day.